We can also be asked to do these normal probability problems in reverse, and that is they may start with the probability or the shaded area and ask you to find the measurement or the value of the random variable. This is called an inverse normal problem. So again, as a reminder, this means you are starting with the probability / area under the curve, percentile or proportion, and you're finding the value of that random variable. Percentile is another word for probability. Okay, so let's see. We are still talking about women's heights in this case. We are going to use technology to find each of the following and sketch the associated normal curve. So how tall is a woman in the lower 30th percentile of heights? So again, percentile is probability. This means we have a normal curve, centered still at 64. But what we have now is, remember, this would be, we know that 64, anything below 64 is the lower 50th percentile, right? Because it cuts it right in half. So either side of that line is 50% of the curve. And they're asking us at what value would we find 30% shaded on the lower end? So it's definitely, I know without doing any calculations, it's somewhere on the left of 64 inches. It's somewhere over here. I'm looking for the value so that below it is shaded 30%. 30% of that curve is shading. To be in the lower 30 percentile of height, it means that only 30% of people are shorter than you. Okay, so what we need to do here is we need to use our inverse normal function. So we're going to open an empty cell and type equals norm.inv for the inverse normal. Type in the probability, the mean, and the standard deviation. So in this case, what it's going to look like is we're going to type in equals norm.inv. The probability that we have, or the shaded area under that curve, is 30%, 0.3, with a 64 mean and a 3 standard deviation. And again, Excel only works these in the less than direction. So if you are already looking for a less than direction, there is nothing additional that you need to tell it in order to do that. So if we're doing the lower 30th, I'm going to do norm.inverse this time, 0.3, 64, 3. And it tells me, notice this is a value, this is that random variable is about 62.43 inches. It's important to know that we have just calculated in inches. So does that make sense that this would be at 62.43 inches? Sure it does. So drawing that normal curve and sort of visualizing, should I be above or below based on what I already know, can help you to double check and make sure that you're using the correct commands. If you use the wrong command, it's not going to make any sense. Okay, what about what's the minimum height to be included in the top 10% of women's heights? So in this case, we want only the top 10% to be shaded here. So somewhere up here, there's a value where 10% of the curve is shaded on the upper side. In order to do this, because Excel doesn't do greater than, it only does the cumulative in the less than direction, what we're going to have to do is we're going to have to find the probability of, or we're going to have to find the value. This value is the same one where 90% is below it. It's the same value. So find the value that 90% of heights are below. I don't need to do any sort of a 1 minus in my calculation. I've already done the 1 minus in this case. I've already said, well, if I'm looking for top 10%, that's the same thing as 1 minus that. That's the same thing as 90% being below it. So when I go to type this in, I'm going to type in norm.inverse 0.9643, and whatever that tells me is in fact the answer. So I just have to basically be flexible with my wording. That top 10% is the same thing as lower 90%. Okay, so it looks like this value is approximately 67.84 inches. And if I look over here, that makes sense for that value to be where it is as far as the height is concerned. What are the boundary heights for the middle 60% of women's heights? Let's think about what that looks like visually as well. Go back over here. And I've got, okay. So if the mean is at 64 here in the center, we want to find what are these boundary heights so that 60% of the values fall in between there. So I have to really do some thinking. If 60% is in the middle, we have to go back and think about how we marked off that empirical rule chart. Then what that means is that 40% is left to be on the tails on either side, which means that there's 20% down here and there's 20% over here. But again, I can't do an upper, I could calculate this, I could figure out, well, what's the value, what's this value here where 20% are below? I can find that value by doing a norm dot inverse 0.264 and 3, and that would tell me this first value here, because that's the same as the value that 20% are below. But how am I going to type in this one? I can't say the value that 20% are above. That's not a command I have. But if 20% are above, that's the same thing as 80% being below. So to find this value right here, I'm going to type in norm dot inverse 0.864 and 3. And that's going to tell me these two boundary heights. I just have to figure out how to put it into Excel in a way that Excel will accept it. So let's see. That for that lower value, we're typing in norm inverse 0.2, 64, and 3. So let's see, 61.48 inches. Does that make sense to be right here? It's below 64. Yeah, that makes sense. And then for the other one, we're going to type in 0.8. So we find that that upper value is 66.52 inches right here. So both of those make logical sense if you're anywhere between 61.48 inches and 66.52 inches is where the middle 60% of heights for women fall. So you can get that written in as your final answer there. And again, these commands will be what I'm looking for full credit. But drawing these associated normal curves is not a bad idea at all to show how you were thinking about solving this problem. Like, how did you come up with this 0.2 and this 0.8? Where did that come from? You're showing me over in your visual why you used those values.